Please, everyone, please again rejoin. So, okay, is everybody aligned with me? So, let us resume the session. Huh? Okay, let me share the screen for the purpose. Okay, sorry. Yeah, I was in here. So I was talking about polynomial regression and I was talking about how good it could be. And obviously, you can play with the values like you can change the degree of the polynomial from 2 to 3. So wiggliness will be more in the code and the performance may be quite good. You can see 97, it is close to 1. So as you can expect, the polynomial regression is quite better than the linear regression. Okay, now let me come back to my previous slide. Now let us talk about maybe for this purpose, I want to consider a different problem. Maybe we all are tired with the previous problem of crop yield prediction. You know now how to do the crop yield prediction. Obviously, we can use the other models like MLP, multi-layer perceptron, backpropagation neural network. You can use for the regression also. That also I may cover with some other example. Now let me try to explain how you can use the k nearest neighbor KNN algorithm for doing both the job of regression and the classification. Suppose I have the n training sample. So in the what is the concept behind the KNN? Try to understand it first. After that, we may jump into the code. So basically, suppose we are having n training points. The k nearest neighbor find k nearest neighbors. So in this example, suppose we take the number of neighbors is 3. So suppose these are the samples, all the red triangles are the training samples and the blue circle is the test sample. Now for this test sample, I need to know what will be the value of this test sample. So is my problem clear to everyone? So for all these red triangles, I know their value 1, 8, 9, 12, 6, 10. Now a new input sample, unseen sample, blue circle has appeared and I need to predict the value of this blue circle using k nearest neighbor algorithm where the k I have considered the number of neighbors is 3. In that case, what will be the value of it? What will be the value of this blue circle? The value will consider, if I consider only one neighbor, then obviously the neighbor has a value 6, so it will also have a value 6. So if the plant region nearer to it having a yield value x, it will also have a yield value x. As simple as that. If I consider two neighbors, so now I have the blue circle having two neighbors, the 6 and 8. In that case, crop yield will be the mean between these two, 6 plus 8 by 2, which will be 7. Now, if I want to consider three neighbors, like the example k is 3. In that case, it will take the average of mean of it. So 1 plus 8 plus 6, which is supposed to be 5. So the blue circle will be having a value, maybe crop yield value 5. So this is how the regression works in. This is how regression works by using k nearest neighbor algorithm. Now, if I want to perform classification task, like upon seeing a sample, I need to decide whether that sample will belongs to class 1 or class 2 or class n. So I need to put the unknown sample, test sample into a particular class. In that case, that problem is considered classification problem. Like, okay, so classification problem, I can say it is like this. Suppose there are few samples are there and there are some other samples are there. So if I draw a line, it will basically separate the sample into two classes. This is class 1, this is class 2. So this is how the classification works. Classification means discriminating sample based on certain feature values, discriminating them. This is the classification problem. It is not like the regression problem. So how we can solve the classification problem using k-nearest neighbor? Suppose these are, as we can see, these are the healthy persons and these are the sick persons. And I need to classify. So how I can use k-nearest neighbor for the classification purpose? So suppose this is a new sample. So for this particular sample, I don't know whether that person is sick or healthy. So if I use one neighbor, the closest neighbor is sick. So I will label this new sample as a sick sample. If I consider if I consider three sample, then two is healthy, one is unhealthy. So obviously the class assigned to this new sample will be healthy. Similarly, okay, there I would like to state another fact. Why I have not considered two? Because there lies a problem. Because in case of classification, end of the day, we need to make a judgment whether that person will be sick or healthy. Now, if I take a even neighbor, then maybe half of the neighbor maybe belongs to category 1 and the half maybe belongs to category 2. So the sample, even number of sample may be distributed in the neighborhood. In that case, it will be difficult for us to judge in which category the sample belongs. So it is advisable that if you need to use KNN for classification, always go for the odd number of neighbors. In that case, you definitely coming up with a majority. Now, finding the K value. Deciding the value of K is the hyperparameter optimization. Now, as we have seen that the k value is very important for getting the answer of knn. So that is a hyperparameter that is we need to judiciously choose to getting a better result in real time. So and measuring the distance, there, as we know, there are many metric are there to measure the distance between two entities in reality, like there's a Manhattan distance. Like if I want to compare the marks between the two student, a student X having marks 60, another student Y having the marks 70. So obviously the difference between the absolute difference 70 minus 60 is 10. So that is a Manhattan distance. Now in reality, suppose two sample are there in a 2D space, like so two samples are there in a 2D space. This may be the x1, y1, this may be the x2, y2. So obviously their distance will be measured by what? Euclidean distance. So in this example, this is Euclidean distance. So I am taking the difference between these two samples by using the square of them for all the samples, and after that I am doing a square root of it. So this is the Euclidean distance. Like there are other distance are there, like if you want to compare the distance between two vectors, how they are correlate with each other, we need to compute covariance, and for that we need to have Mahalanobis distance. Like if the things are not so linear, we may need to go with the Minkowski distance. So that is out of the scope of this session, so I'm skipping those. So currently you need to focus on the Euclidean distance only. So for classification problem, K should be odd. I think I have discussed this thing. So let me go back to the next slide. How it can be computed the Euclidean distance? Suppose two samples are there, and for those two samples, this is how you can compute the distance. So here, as you can see, I have considered the example of this, the distance between these two, the distance between these two, and finally the distance between these two. And if you add them up and square it, you are going to get the Euclidean distance. Okay, threefold cross validation is not required in here. So let me, now I am going to use another example for this purpose. So now I am not going to solve a regression problem. I am now going to solve a classification problem. And with obviously with another example. So okay, discard. Okay, what example we are going to consider? Let me see. So now in this example, I am going to consider a leaf, and the name of the flower is iris flower. So I want to, okay, as you people can see all my skin, so iris flower. So this is the iris flower, and for this iris flower, I need to judge. Now there are three types of iris flower: the iris versicolor, the iris setosa, and the iris virginica. So there are three kind of iris flower is there. So from some suppose some agricultural land, I want to distinguish that which flowers are iris versicolor, which flower is iris setosa, and which color is iris Virginica, and I want to assign a robot to do that job, then the robot should have some able intelligence to correctly pick the flower. Like if I want to ask that robot to unplug iris versicolor flower for me, then the robot should go correctly identify the flower and unplug it and give it to me. So in this example, the classification is very important, and how we can do based on certain feature of these flowers. So what are the features? So basically sepal length in centimeter, sepal width in centimeter, petal length in centimeter, and petal width in centimeter. These are the four features for the purpose I'm going to use. So this is the sepal length and sepal width, their width and height, and this is petal, this is petal length and petal width. So these four parameters based on which we can classify them. So these are the four. Okay, this is not required anymore, not required anymore. So in this example, this is the data. So these four are the input features, and this is their label. So these flowers comes under the category of iris setosa. Some other flower may be there, which their parametric value comes under the category of iris versicolor, and the third sample there come under the category of iris virginica. Up to this, is it clear to everyone? What is classification problem and how it is different from regression problem? I want to, you can unmute yourself and ask that question to me. And after that, I will jump into the coding part because until unless we have the knowledge of what is classification, it would be difficult for us to grasp the code out of it.
It's clear, sir.
Okay, thank you. So now I am going to use the same strategy like I am going to use the pandas because end of the day these all values I need to store in a table because these are all numeric values. So I am going to use pandas. I may wish to plot it in a computer. So matplotlib I have used, and after that this is how you can fetch the data using URL. Suppose you want to run your code on a data, so you can put the code in a GitHub, or there is a way you can put the data in your Google Drive, and after getting the permission, access the data from Google Drive, or you can upload the data in directly into the Google Colab. These three options are there, but the most I prefer this that the data should be there in the GitHub and directly access the data from the GitHub. And the code again can also be in the GitHub so that any publicly available data I can put that in a GitHub, and the people who are associated or want to access my GitHub, they can get the data. That is why I prefer to put the data in a GitHub. Um, so okay. So features are what? These are the features: sepal length, sepal width, petal length, petal width, and species. These are all features. But however, as you can know, this species is basically the class level. So this is actually the output level. And what this line says? This line says in the Python that I want to read line from line number one. And as I have talked earlier, then Python everything start with zero. So I need to ignore the line number zero and I need to start computing from line number one. Why so? See, the first line is talking about the parameter name or column names or feature names. So that is why this is not actually the value to be computed on. So that is why I have started reading from line number 1. This is line number 0. Python and C, everything start with 0. Okay, so the data is with me and ahead I am going to print top 5 values. So as you can see, these are the top 5 values where these are the features and these are the labels or class labels. Now, obviously, this is the training, the input features. So first 4 column from column 0 to column 4. So column 0, 1, 2 and 3. 4 means it is excluding the last one. So I'm going to consider all the rows. After that there is a comma. So before comma these are row representation and after comma this is column representation. And as colon is there, so that means all the rows is going to be considered, and 0 to 4 means I need to consider 0, 1, 2 and less than 4 is 3. But 4 is not less than 4, so 4 is not going to get considered. So I will consider the column 0, column 1, column 2 and column 3. So this is input features. After that, the fourth column, you can see all the rows I'm going to select and only column. Here is no column. Only 4 is there. So only column number 4 will act as a class label or class label. Is it clear? I have segregated the data into classes. If you want to see how it look like, so I can help you in that. I should not have printed all. Instead, I should have used head to print only first 5 values. I think there is some internet issue. It is taking little time. Okay, sorry. This is capital X, na?
Sir, can you please share the code?
Oh, is it not visible? Oh, sorry again. Okay.
It's visible, sir, but we can try in real time.
Yeah, I have shared the code in there. I guess you can get it over there. I shared in chat box. Did you get the code in from the chat box? I have provided over there. Okay. In the
Sir,
meantime,
it's
let us.
polynomial one, I think. I have not shared this
Oh,
one.
okay. No issues, no issues. Let me share the code. No issues. This is the code related to KNN, which you can play with. Now, this is the input features. As you can see, input features are 4 values and the output will be only the class level. So it's all okay. We have properly extracted the label and input features from the data. Now, this is quite interesting. Grid search. There is a search called linear search, grid search. Why this is required? Because the performance is dependent on the value of k, the number of neighbor in the KNN. And that is why optimally choosing the hyperparameter value, that means the value of k, is very important. And that is why we should not train our model on a specific value of k. Rather than we should train our model on multiple values of k and after that try to understand which k value is best for this model. So that is why grid search sim is there. It is like it is created grid and for each element of the grid it evaluates the model. So grid search CV is used for grid search. After that, stratified K4 cross validation is a variant of K4 cross validation. I wish everyone knows it. And after that, the Escalon neighbors, where the K neighbors algorithm or classifier is there. And after that, these are the metric related to accuracy. The earlier, whatever metric we have talked about, those metrics are related to regression problem. Uh, However, in case of classification, metrics are like accuracy score, recall, precision, ROC curve, AUC curve, confusion matrix. These are the metric related to the classification problem. Now, in this example, I am going to create an object called model from the k nearest neighbor classifier. And after that, see, instead of a single value of k, I am going to consider a range of values for k. So value of k may be 1, the value of k may be 2, and as it is written 31, so it is going to consider 1 less than 31. So it is going to consider the maximum value 30. So I am going to consider the value of k as 1, evaluate the model, consider the value of k as 2, evaluate the model, like that consider the value of k as 3, evaluate the model, and on a particular value of k, the model will give the base result, and that particular k which we obtain from the training data, I'm going to use while testing the model. So let me run this model. So here parameter grid. Parameter grid is a dictionary. Dictionary like that, and number of neighbor is k range. So it will be a dictionary like k equal to 1, k equal to 2. It is like a key pair value. Those who are familiar with JSON, they can understand it better. So dictionary like there will be a key value and a pair value. Comma separated, precisely colon separated you can consider. So key and this is the value. And in this example, the left will be k, right will be 1. Next example, k and colon 2, like that. So this is a key value pair. This is called the dictionary in a Python. And I am going to use stratified K4 cross validation. You can use normal K4 cross validation, no problem with that. So I am feeding the model. Model is the k nearest classifier in my example, parameter grid. All the values of the k I am going to consider. The stratified K4 cross validation, X is the training data, Y is the training label, and based on which our performance is going to get evaluated based on the accuracy. If the accuracy is high, it is good. Accuracy is low, bad. And after running the code, this is my architecture of the model is built. And after that, let me run the code. This is the value which we have obtained. And there, as you can see, for all 30 values, all 30 accuracy values I have obtained. But from there, suppose instead of 30, I could have considered 3000. So in that case, manually debugging which k value, for which k value the accuracy is maximum, it's quite difficult. So we should, rather than doing all those things, just run this code and plot it. We can see for certain values the accuracy is maximum. Like these, for these values the accuracy is 98. So consider any one of those k values and evaluate the model. So if I run my code using the k value, so here I can see the k for value 14. When the k value is 14, the model is working perfectly. Now, again, we have to use certain concept. Like I could have considered these values also, but if the k value is less, it will be easier for us to the computational cost may be less, and due to that reason, I have considered the minimum among these 40. So after evaluating the problem, we can see this is the confusion matrix. This is the precision of the model, recall, F score, and the support, and the accuracy is 98% for class-wise as well as overall accuracy. So this is how you can use KNN to perform a classification task on any data. And in our example, it was agricultural flower data iris. And I wish everyone having okay, let me explain this part of the code, like how I am plotting it. So basically, this is the grid search. After that, the CV result. What is CV result? You can see in this code, I could have omitted this code. So basically, grid set cv dot keys. Here, if you go back in here, this is the parameter grid, and this is the grid set cv. And after running the code, it will have a grid it will have a grid object, and with the grid object I trained my model. And after the training my model, the grid search CV result is another key, and it is giving me the key values on the result of test accuracy score, which is obtained from this line. And after that, if you run your code, and I have printed all the values of the accuracy based on the k value. So for k value 1 this, k value 2 this. So this is a simple for loop where first parameter is parameter. That means the different parameters like mean, fit time, STD, standard deviation of fit time, like that. And after that, the mean test score, STD test score, and these are the accuracy values. And from there I basically plot this mean test score, and corresponding the value of k. We obtain the from training data, we obtain that the for k equal to 14, it is giving best result. So when I get to know that this k value is ideal for this data, so I have taken the data, I have split the feature and output label differently. After that, I have taken all the values from line number 1, because line number 0 is not required for computation. After that, this is the predicted value. This is the k nearest classifier, and you can manually assign the number of neighbor in k nearest. So earlier, while we were using k nearest neighbor, we have not put any features. But now I know that for k equal to 14, we are going to get the best result. So here now in neighbors equal to 14, I am assigned this k nearest neighbor classifier will have 14 neighbor. After that, this is the training data. This is the training level. I train the model with this configuration. After that, I need to predict the model on the predicted data, which was not seen earlier. And I print the confusion matrix. So confusion matrix I have imported. You can see from sklearn metric import confusion matrix. I have imported the confusion matrix. So in the confusion matrix, I need to present the real output, predicted output, and these are for labelings. And after that, I basically print the confusion matrix values, which you can see below, along with their precision score, recall score, and every other things. So this is how we got the output. So as we can see, for iris setosa flower, it has perfectly identified all the 50. Okay, I needed to tell you that there was 50 samples in the iris flower, where 150 number of samples of iris flower I have taken in this example. Among them, 50 comes under the category of iris setosa, 50 comes under the category of iris versicolor, and rest 50 comes under the category of iris virginica. So from the code, we can see that all the 50 iris setosa flower has been correctly identified, but iris versicolor flower 49 has been correctly identified, but one has been wrongly identified as iris virginica flower. Similarly, in case of iris virginica, among 50 iris virginica flowers, that is the last category, 48 has been correctly identified, but 2 out of them has been wrongly identified as iris versicolor flower. So overall, 3 mistakes are there. So 3 flower has been wrongly identified out of 150 flowers. So basically, if you could plot it in a 2D space, you will observe that there is no overlap between class 1 with class 3 or class 2. However, there is an overlapping region because between class 2 and class 3, and due to that reason, it sometimes falsely identify versicolor as virginica or virginica as versicolor. So this was again a very simple example for clear understanding. Now I think I need to talk little about advanced models
Sir,
like, okay, ask
yeah,
me.
sir, yeah, sir. Recall and FI score. What does it explain in the result section?
Yeah. So basically recall and precision, these are depend on various factors like, okay, for better understanding, I don't know I will get that much time or not. Okay, still try to explain it with easier example. Do you have the concept of true positive, true negative, false positive, false negative?
Yes, sir.
Yeah. So you know what is true positive, what is true negative, what is false positive, what is false. Okay. This slide may not have that info. Okay. So recall you are seeking for now. So recall is basically true positive divided by true positive plus false negative. Now what is true positive? What does that interpret? It interpret that suppose in this example, suppose let me consider this one. So basically there was 50 iris virginica flower. Among the 50, okay, in this example, I have used, I discarded a few sample for testing and few sample used for training. So in this example, basically, 49 total iris virginica flower is there. Among them, five sample has been wrongly identified as versicolor flower. So in that case, overall sample was what? 49. So true positive. That means the positive, it is the class is actually Virginica and it has been identified as Virginica. So true positive is 44 and false negative. That means it is a Virginica flower. It is actually a Virginica flower but falsely identified as negative, means non-Virginica flower. So here the false negative is 5 and true positive is 44. So 44 divided by 5 plus 44, 49. That will give you a recall value. So you got it? 44
Yes,
divided
sir.
by 49. So this is recall. Recall, if you go by the biological analogy, then recall means how much we can recall, remember, na? So from 49 iris virginica flower, I can remember 44 and I fail to remember the rest 5. I put it into the referent bucket. So you can draw an analogy like that. Recalling means overall sample is there and among them how many of them you are correctly identify. Is the analogy clear to you? Okay, I hope it is.
Yes, sir. Yes.
Now what was the now to know the ape score you need to have the knowledge of what you need to have the knowledge of precision. Precision is something else. Precision means how many you are properly I think the okay, precision is there, yeah, precision also there. Precision is true positive. But rest of the four
Actually,
are
you're not
wrong.
here.
Suppose you assign a person to bring Virginica flower for you. So he has or she has brought 50 Virginica flower for you. After inspecting, you are seeing that 46 are actually Virginica flower, but rest of the four are not actually Virginica flower. So they are basically falsely positive. So among our, so how much perfect our model is that the person who actually go there to bring the flower for you, how much perfect that person is, that basically represent the precision. Now F score in general are basically the average of precision and recall. Is it clear what is F score?
Yes, sir. Thank you,
Okay.
sir.
Okay. So now I think not much time left with me. So let me quickly talk about certain CNNs, because the in agricultural land majority of the time is my slide visible to everyone?
Yes, sir.
Yes, it
Okay.
is visible. Kindly
Okay.
make it
Thank you.
full screen slideshow.
Yeah. It would be nice to start with here because the rest of the I'm assuming everyone has the prerequisite of CNN or convolution neural network. So many times, suppose we need to detect whether there is a disease in the agricultural land or not. And if some plant having some disease, we need to uproot those plants so that it do not spread. So we can apply a drone. Drone will picture of that land, and based on drone images, we can judge which area is infected, which area is not. So majority of the time, we need to deal with image data instead of numerical data. Till now, whatever data we have used, those are numeric or maybe image data and interpreted into a numeric data and evaluated, like in iris. But sometimes we may wish to work with the direct image data. So how we can do that? For image data, dealing with the image data, the best possible way is the convolution neural network, because they have they take care of like image. Obviously, the pixel associated with in the neighborhood of a pixel are the better representative. Obviously, if I take a picture of a human face, obviously the pixel which is related to ear must not be close to the pixel which is representing my lip, because they are quite different. So obviously all the pixel which is representing my lip, they should be in a close neighborhood region, and all the pixel which is representing my forehead, that should be in a very far away region. So obviously this neighborhood knowledge most of the time do not have normal backpropagation neural network like MLB. Most of the time they do not have. So it is better to use some other model which have the characteristic to do with it. Okay. Okay, so this is a convolution. This is why I'm talking about this convolution neural network, because it is not the optimal. It is the easiest convolution neural network. Frankly speaking, this is the first convolution neural network which having only 5 layers, as we can see. That is why it is called LeNet 5, and he was the scientist who invented it, LeCun. So that is why it is called LeNet. This is the philosophy behind the nomenclature. And this is the image data. Suppose you are having an image data, it can be any image data, it can be crop data or any other data. After that, we apply the convolution operation. I hope many lectures has been discussed about what is convolution. So after applying the convolution, it basically pick up the features from the input image. After that, it apply the pooling. Pooling is just to reduce the resolution of the image, come up with a better solution, and you can apply this combination of pooling and convolution multiple times. In this example, I have used twice this combination, convolution pooling, again convolution pooling. You can apply this combination numerous number of times to extract as much information as possible from the image data. After that, you need to feed it the value in a fully connected layer, or you can apply the global average pooling layer, and finally you can do the classification. So yeah, this was the scenario with Lenet. So basically, input image is a 20 by 20, sorry, 28 by 28 pixel, which is you can understand. This is a very simple image. Reality, the image is not so simple. Image nowadays having a resolution like at least 680 cross 4, 640 cross 480 VG image. Now, so obviously you can understand how much complex the computation will be. After that, I have applied a kernel, a 5 by 5 kernel, convolution kernel, and 6 output channels I have used. And to do not lose the border region information, I have used padding too. So after that, I have used average pooling. So I prefer everyone, I suggest everyone ignore average pooling, use the maximum pooling. After I have applied another convolution layer with 5 by 5 convolution kernel, and output channel is 60. After that, I have used average pooling. And finally, I have fed all the data, means club all the data in a single dimension, make it a fully connected network, and I classify. Finally, output class is 10, so that is why 10 there. And this is how you can build a CNN model and evaluate. For the understanding, let me again jump into the code, because hands-on is important now. Okay. Let me see whether CNN code is there with me in this here of Linux. Linen code is there. Okay, I'm supposed to say the code as well now. So let me see. So, okay, I've said the code of Linet. Done. How you can build? What is the easiest possible way to do that? Okay, so for that purpose, let me run this code. Okay, I have run many codes, so maybe it is restricting me to run it. Give me a time. I need to manage session, terminate other sessions. Let me run it again. Okay, as it may take time, as I can see, in the meantime, if anyone having any doubt related to CNN, they may ask me because it may take time, I am assuming. Anyone having any question, they can ask me in the meantime.
Good morning, sir.
Good morning.
So I have a query. Actually, we are using data set for something for training and some other things for testing. What is the percentage
Right.
level for testing and the training, sir?
Sorry, I couldn't hear you properly. Maybe network issue.
So we use data set. Some data among the data sets, some data are used for training, some others are used for testing. What is the percentage level of testing and training, sir?
It depends. It depends on you. I preferably use 20s to 10 ratio, 20s to 10 ratio. Suppose you want to break your data into a training data and a test data, it is wise to divide the 80% of the data as a training data and rest of the 20 as test data. Sometime if you have validation data, like for validation testing. So in that case, I suggest you to use 70% of the data for training, 20 for validation and rest of the 10% only for the testing. So 70 training, 20 validation, and 10 testing. But again, it depends on the choice of the developer. So it is no, there is no hard code rule that this many should be used for training, this many should be used for testing. It is up to you, but these are the conventions followed by the developer.
Okay, thank you, sir.
Any other question from CNN? Because I am currently jumping into the code, as you can see. I am just evoking the TensorFlow and maybe going to use TensorFlow for the implementation. You can use PyTorch.
Excuse me, sir.
Yeah, tell me.
Sir, actually, how that value of k is assigned in KNN model?
Yeah, as I have discussed now that in KNN your okay, this is it will say it has been changed, I guess. The library has been changed. Okay, so in KNN, you need to check with multiple values of K, and with the validation validation data set, you need to know which value is perfect, which value of K is perfect. Okay,
Sir,
and based on
can it be automatically unsupervisedly it can be done or not? It's automatically the code
in
will
the
automatically choose the value of k.
in the
Means
previous code,
optimization will be.
in the previous code it has been choose optimally only. If you can recall the code, I was performing a grid search and based on that it was picking a value of k. Now we can run like max index, and after that all the metric value you can put that as a variable, and you will get the maximum the maximum value on for which k value you are getting the maximum value. So you can take the value and put that numeric variable and pass it while testing. So obviously that is in previous code also that has been done automatically, not manually. Is it clear?
Okay, sir. Thank
Is it clear?
Yes, sir. Thank
So you will
Yes, sir.
perform a grid search, and after the grid search, you just need to write a simple one line of code that restore the value of k for which we are getting the maximum value. That single line of logical code you need to write. So it will have a value k max like. So for a value of k, we are getting the maximum value. Now you just when you are doing the testing, that time you will need to use n underscore neighbors equals to k max, and it will work on the k value for which it is giving the best result. And nothing you need to manually go and check the value of k. It is grid
Okay,
search,
sir.
but obviously, as I have discussed, grid search, there are the other searches are there which you can use for optimally getting the value. But end of the day, you need to check with numerous values of k, and then only you can get to know that for because the value of k depends on the data set which you are applying. So obviously, you need to try with all values of k, and then only you can judge on which k value it is giving the best result. So there is no other way.
Okay, sir. Thank you, sir.
Okay. Okay, then I think I have my installation are all done in my Google Colab. So as you can see, this is all known to you. It is like to importing any random value. This is NumPy has been discussed earlier. Matplotlib, and this is TensorFlow. This is a package which we can use for performing the CNN kind of high computational task. And after that, there was some issue, so I have uninstalled, reinstall it. After that, okay, why I'm doing so? Sorry. So after that, you need to import Keras preprocessing. After that, from there, basically, the architecture, building the architecture of the CNN or defining the libraries. So defining is going to all the module required to design a CNN. So keras.module sequential. It is going to import a sequential module. After that, keras.layers, all the layer like dense layer, flattening layer, max pooling layer, average pooling layer, and it is working on 2D data. So max pooling 2D, average pooling 2D, conf 2D. These all the modules I have imported. The dataset in current example I need to use is MNIST dataset. After that, this is too categorical to convert the data from numerical value to categorical value. And after that, so basically the image resolution is 28 by 28. But as the network is supposed to receive three-dimensional values, so I have converted this two-dimensional image in 28 cross 1. And number of output class means different type of image is 10. So that is why n class is 10. After that, I split the data into training data and the test data. So this is training data, training data. This is test data. This is training level. This is test level. After that, I done some reshaping. So we can see there are 60,000. This is a real world data, and it is having 60,000 training data with resolution 28 by 28. And obviously, as there is a 60,000 training data, so training level will also be 60,000, and each level may be level 0, level 1, level 2, like that. So it is having a level value. After that, if you want to plot the image, it is not exactly the agricultural image data, but that can be imposed. It is a numerical digit recognition data. So this is 504. This is how you can plot the data using the matplotlib.pyplot function. Within there is a subplot. I am so it is going to show you the image. This is how you can see the image. And after that, I have performed some normalization, because all the pixel may be having any value from, if it is a grayscale image, as immunized this is a grayscale image, so obviously all values will lie between 0 to 255, because every pixel has been represented by a 1 byte. 1 byte means 8 bit. So how many configurations they can have? from 0 to 2 to the power 8 minus 1. So 0 to 255. And that is why every pixel may have a value between 0 to 255. So I've divided each value by 255. So now every pixel will have a value between 0 to 1. So this is a simple normalization I have used. If you want to prefer use some other normalization, you can do so. After that, I have converted the value from label value to a categorical value. Like label was earlier 0. Now, how many classes is there? There is a 10 class. So the 0 will be represented with 10 values. So 1 and after that maybe 9 zeros. So this is how I am going to represent 0. So 1 will be represent how much, what is the way to represent 1? So the 1th bit will be 1 and rest of the bit will be 0. And why I have used 10 bit? Because 10 number of classes there. For 2, the second bit is 1. 0th bit is 0, first bit is 0, second bit is 1, and rest of the bit will be 0. So this is the job of two categorical function, because end of the day in a CNN there will be 10 number of output nodes, each representing a class. So obviously the output, as there is a 10 nodes, so here also your label should have a 10 value. So that is why I have converted into a categorical value. Up to this, is it clear to everyone? Maybe I'm hurrying a little bit. Up to this, is it clear to everyone?
Yes, sir.
Okay, good. So after that, what is the task? I need to build the architecture. Like when we are building a house, first of all, we need to design it. So design part has been done, and after designing, we need to create it. Create the architecture. So here I am creating the CNN architecture. First of all, the model will be sequential. Like in CNN, it is not possible that you are directly feeding the value in here. Obviously, the input will go to first convolution layer, first pooling layer, second convolution layer here, second pooling layer. So value will be passed layer by layer sequentially. And that is why the model is called sequential. Okay, where was I? Yeah, sequential model. After that, add, and I am applying the first layer will be what? Add means adding a layer. Now, first layer was convolution layer. And what was the config of the first layer? Okay, let me put it parallelly side by side. It may be help everyone to get it. So, as we can see, voice. Oh. As we can see that the first is what? The kernel is 5 by 5. The filter number of output channel or filter is 6. Padding is 2 is used. Here you cannot put the padding value as 2. In Keras, the option is the valid padding and same padding. Same padding means padding is there so that the resolution of the input image do not change. So same padding means after applying the kernel on the input data, the resolution of the input image will not change. That is why it is written the same. Same padding means the padding will be applied in such a manner that the resolution of the input image do not change. So that is why I have written same padding. Input shape, as I told earlier, that I have changed the 2D to 3D. So it is 28 cross 28 cross 1. It is three-dimensional image now. And the activation function, the LeCun, when he has invented, he has used sigmoid activation function. That time ReLU activation function was not invented. So that is why he has used sigmoid. I suggest everyone to go for ReLU activation function because that is obviously better. Now next layer is what? Next layer is average pooling. Again, average pooling is not good. I suggest everyone go for max pooling. But that time he has used, I am basically replicating his exact model. That is why I am using average pooling. But nowadays, due to evaluation, people come to know that max pooling is better. So I suggest everyone to use max pooling. But as he has used average pooling, I am using average pooling over here. And after that, third layer is again a convolution layer. So conv2 is convolution, representing convolution layer. Kernel is 16, as you can see. Kernel size is 5 by 5, as we can see. Valid, there is no padding, so valid padding. Activation, he has used sigmoid, I have used sigmoid, but obviously you should use ReLU. After that, there is another pooling layer where the pooling size is 2 by 2, average pooling layer, pooling size 2 by 2, stride 2, and there is no padding, so padding is valid. After that, he has flattened all the data in a fully connected layer. So flatten it means concatenate all the layers in a single layer. After that, he has used a dense layer, fully connected layer. Number of nodes is 120. Activation function, he has used sigmoid. That is why I have used sigmoid. Suggest to use ReLU. Next is fully connected layer with 84 hidden nodes. Activation function again here is sigmoid. And the final layer is end of the day. You need to classify a particular image on a category 0 or category 9. That means the image can belongs to any of the 10 classes. So obviously, in a finally, you need to have a discriminative activation function like softmax. Softmax does what? Among the, so obviously the 10 hidden node all will having some value based on certain input. Now a particular hidden node will have a value maximum among all, and softmax function give us an output like this. So if I use like 1, 3, 5, 9, 8, 7, 4, 22. So suppose these are the values are there. Now among them, which one is the maximum? Okay, then use maybe 2. So obviously among them, this is node 0, node 1, node 2, node 3, node 4, node 5, node 6, node 7, node 8. So node 9, node 10. So these are the nodes. Now among them you can see node output node or output neuron or output last output node or unit is giving the maximum value 89. So winner is class 9. This is the job of softmax function, and this is how you can perform the classification. So I need to run the code to show you the output. And as the data is too big, so we use batch normalization. I don't have much time, but I can show you this is the accuracy you are going to get around 98% accuracy. And this is how you can easily build any convolution neural network. Now, from here, I would like to stop my presentation. If anyone having any question, they can ask me now.
Good afternoon, sir.
Yeah, good afternoon.
Sir, I have one question. As you are, you have explained the LeNet architecture for the 2D CNN for the classification. If my question is that if we are using same architecture for 1D CNN as LeNet architecture, so it is if we want to publish an paper based on 1D CNN in which we are using LeNet for 1D CNN, so is we can say that it is Linet or yeah, Linet, like in some paper I have seen that they are using some other word for that.
Actually, every CNN architecture has a different name based on its architecture. So as you are going to use 1D CNN, so data will be in one-dimensional vector form, not in a matrix form. So obviously you need to customize the lineage. You cannot use the ideal lineage for constructing or implementing 1D CNN. So obviously that will no longer be a lineage because lineage has a specific configuration which you are changing or updating. So as I can say that.
Sir, I am using same architecture, same layer, but instead of con 2D, I am using con 1D.
Okay, so in that case, what is the resolution of the image? It will not look like 28
No,
cross
no.
28. It will be
If you
different.
are using 28 by 28, so I am using 32 by 32 image, and in one and converting it to 1D array, so it is 1024 length of array samples. So it
Okay,
has a
so now my question is that if now it become 1D CNN, how you are applying the kernel over it? So kernel is it 5 cross 5 or anything else?
the kernel will be the 3 by 3. My convolution 1D number of filter 64 and kernel size is 3.
Yeah, so kernel size is 3 or 3 cross 3. Let me know that.
Sir, as passing argument, it is 3.
Yeah.
I think
Why?
it's 3
Why
cross
is it
3.
so? So that is there lies the concept, and there lies the thing I needed to tell you, that obviously as it was image, so you can run over a 2D kernel over it. Now, as it is a 1D, you cannot run a 2D kernel. You need to run a 1D kernel, and there lies the changes. So now, obviously, you are doing certain modification on the existing lineage. So you
Yes.
can say. You can give a different name. You cannot simply say that you can say like 1D LNate, like kind of name you can propose, but obviously you should not use the exact LNate because
Okay,
you are
okay, sir. It is
changing something.
like Linux, but not exactly the Linux.
Yeah, yeah,
Okay.
that is what you need to do. Okay.
So we should use different name in the papers while publishing.
I
So,
suggest you that. But again,
okay.
you need to talk with your collaborators regarding this.
Okay, okay. Thank you, sir.
Thank you.
Sir, can you please share this code too?
Yeah, I guess I have shared. Please see the chat box. I hope I have shared this code. Any other question? Please ask.
Is there any other query? Otherwise, we can uh, complete this lab session. Okay, so I hope there is no other query. Okay, so very beautiful session, lab session by Prasenjit. Okay, and I hope that it's really good for all the participants as they are getting the online or real time test for running the codes and getting the results. It's really good for this hands-on session is really good for that implementations of different idea in that agricultural. Okay, so thank you, Professor Prasenjit. So we can conclude this lab sessions.
Okay, thank you. Thank you so much.